Hello friends, how are you all? In this video, I'll show you a demonstration of OpenPLC program and its integration with ScadaBR. And this is the ScadaBR screen you can see. And I'll also show you how we can control or hack this program using a Python program called Pymodbus from another system, which is Kali Linux. The purpose of this video is to show how vulnerable a Modbus protocol is. We can easily manipulate the settings and manipulate any industrial process. So this is a program which I have written on OpenPLC. This is a simple timer counter program. I've used two timers, T on and T off, which will create a pulse each 1 second, and this pulse will enable the counter which will count till 10. I've set C counter max as 10. Whenever it reaches 10, the output Q counter Q will turn on and it will reset the counter. So this is a simple program that I'll be using, and I'll put this program in OpenPLC runtime, which is installed on Raspberry Pi. I'm using Raspberry Pi 02W to run my OpenPLC program, and this is the monitoring tab where I can see the values of each program. So next we will see how we can use Kali Linux to manipulate these settings. Right now you can see the monitoring tab where each settings are being shown. Also, you can see this ScadaBR screen where I have created a simple HMI screen. I'm showing that this counter is filling a water tank, and you can enable or stop the counter from these counter settings. So this is also a very good open source HMI tool which I'm using here. So you can see that whenever I am uh, toggling the switch, the corresponding status is also being changed. So counter running, if I'll push it, it will reset, and correspondingly you can see that the counter reset variable has changed to true. Now you can see that it would have changed to false. So you can see that it is completely being controlled by HMI right now. Now I'll show you how we can control this using Pymodbus. Now I've started Python. I'll import uh, Pymodbus TCP client from this Pymodbus module. This function will be used to connect to the remote PLC or HMI screen. So I've now imported this. Now I'll create an object called client. Then I'll connect it using the function modbus TCP client, and I'll give the address of where the PLC is hosted. In my case, it is 192.168.137.3, sorry, 1. And then I'll check if it is getting connected. So I'll connect it using, and if it shows true, that means I have successfully connected a PLC. Now I'll be able to manipulate read coils or write registers, whatever you want. So right now you can see that the counter enable is true. Counter enable is a coil, so we can check its status as well. So let's see what comes up. So this is a command I'll be using. Okay, so it is RR means read recipient. I'm using this for my convenience. You can make anything you would like. So it comes out to be 10. Okay, so actually we have retrieved counter max because I wrote read holding registered, but counter enable is coil. So we need to write a command which is called client.connect, sorry, client.read coils, and I'll pass the address of the coil which I have to read. Then I can see the values using, okay, I've written coils, I have to write coils. It will now show using ara.bits. I can see the values of these. You can see it is true. Actually, the Pymodbus puts all the 8 bits, well, status of all the 8 bits. So in my case, there are not 8 bits, but only 3 bits are being used. So first bit is counter enable, which is true. Now we can modify it using write coil command, and we will pass the address that command and what value we want to set. So let's see how we can change that. So write coil and we'll write 0. Earlier it was 1, it was true, now it has become false. Okay, you can also see here it has become counter has been disabled, and also now we can change it to 1 again and can see correspondingly that it has enabled, and same we can see on the HMI screen. So in this manner we can manipulate the settings using Pymodbus. So Pymodbus using Modbus TCP on port 502 is very vulnerable, and we can secure it using segmentation in our networking, VLAN, making VLANs, and using firewalls, industrial firewalls, etc. So we should make our industrial systems secure by using these techniques, like using Purdue model, which segregates different components in different zones. I hope you liked this video. If you like this video, I'll be happy to demonstrate you how have I set up this lab on my system. In the coming videos, I'll be showing you more about these things, that is OT cybersecurity. So stay tuned and do subscribe, like this video, and also if possible please share with your friends. Thank you very much.